Hi, everybody. Today starts day 3 of our working with linear inequalities. These past couple of days, we focused on skills, graphing and shading on the coordinate plane, and now we're going to take all of that prior knowledge and start applying it to real-world scenarios. So notice the title of today's notes, 4.3, day 3, real-world standard form inequalities. The directions here are read the real-world scenario, define variables, write the inequality, and find one possible solution. So we're going to use this first question as a way of warming up our brains on how we're going to approach this. Winter is on its way, and you start a business shoveling snow and salting driveways. You plan on charging $50 per driveway for the shoveling and $5 per driveway for the salt. You want to earn at least $500 this winter. Write an inequality to model. So let's underline our question because that was always helpful to us in the past. Write an inequality to model how many driveways you must shovel and salt to meet your goal. Then find and describe a solution. Being asked how many should be a blast from the past to AX plus BY equals C systems. We're not working in systems anymore, but we still will be building an AX plus BY inequality. So how many tells me that I'm going to define my variables as X and Y. X, well, what are we talking about? How many driveways you must shovel and salt. So X will be number of driveways shoveled. So how many you shovel, and then the number of driveways that you salt, because you're charging different rates for each. Is salted a word? Let's go with salted. So how many driveways that you shovel and how many that you come and you put salt. If we go back and read for information, you plan on charging $50 per driveway to shovel. X represents the driveways that you shovel, so this will be $50 per driveway that you shovel plus $5 per driveway that you salt. Y represents the number of driveways that you salt, so 5Y. And you want to earn at least $500. That's a total, which will be greater than or equal to 500. So my inequality is 50x plus 5y greater than or equal to 500. We've written our inequality. It says now to find and describe one possible solution. So because this is an inequality and not an equation, there's actually infinitely many points that could work, because when we were graphing on a coordinate plane, you shaded an entire half of the coordinate plane, and it kept going forever and ever and ever in all directions, the half that you shade, right? All of those points work. So here we're going to just try to find one solution. So let's say that you decide you're going to shovel 6 driveways. Shoveling 6 driveways would be a value for X. So we're going to say let X equal 6. And this is totally valid. Let's say you're doing this by hand and you know that you can only manage to do 6. So that would be 50 times 6 plus 5y, and you still want to earn at least 500. So we're saying, let's say you're going to shovel 6 driveways. Let's figure out how many driveways you would have to put salt on to still earn your goal. So to solve this, 50 times 6 is 300 plus 5y greater than or equal to 500. We'll subtract 300 from both sides. Draw a line across. So you get 5y greater than or equal to 200. To finish this up, we'll divide by 5. You're either comfortable doing that in your head, or you're going to press pause right now and go get a calculator. What did you get? I get y is greater than or equal to 40. So what does this answer mean? Y greater than or equal to 40? Well, y represents the number of driveways salted. So our real world meaning is if you shovel 6 driveways and salt 40 driveways, or let's be more clear on that, salt at least 40 driveways, you will earn at least $500, which was your goal. And this is one possible solution. You could have plugged in 2 driveways, 5 driveways, 10 driveways, and used this inequality to figure out, well, I'm assuming I shovel this many, how many do I need to salt? Or you could have started with values for y. Let's say you have 10 houses on your street and you think all 10 will say yes to paying you the $5 to put salt on the driveways. Well, let's say I put salt on 10. Let me go figure out how many I'd have to shovel to get my $500 goal. Now that we have an idea of how these are going to be constructed, let's really jump into our first official example of standard form inequalities in the real world. Your cousin's graduation party is a video game party at the arcade. Each person at the party receives a card with 50 points on it to play the games in the arcade. One of your favorite driving games uses 12 points per game. You also like a basketball game that uses 8 points per game. You want to determine how many times you can play each of these games without exceeding the 50 points on the game card. From the question, I will know how to define my variables. It says how many of each type. So what are the 2 types? Well, you are playing a driving game. So how many times do you play the driving game? So X will be number of times, number of driving games. And then the other game is the basketball game. So Y will be the number of times you play the basketball game. So I don't know how many times I can play each of these yet, but I do know how many points they take. I know that the driving game uses 12 points. So 12 points per driving game plus how many points to play the basketball game? How many points to play the basketball game? Well, I read again and it says 8. So plus 8y, and you cannot exceed the 50 points. So this has to be less than or equal to 50. That's that total it's giving me without exceeding the 50. So I will set this less than or equal to 50. The fastest way to graph this is by intercepts, which is why on the skills day, we had you practice finding intercepts instead of solving for y, because technically I could subtract 12x and divide by 8, but with these real-world scenarios, we're going to be dealing with much bigger numbers. Sometimes we'll have decimals, so the fastest and best way is intercepts. A reminder from yesterday's notes, to find the x-intercept, let y equal 0. And we want to have that title in our notes. It takes a second to write it. Okay? So let's write it. And we're going to follow this as a set of directions. So let's let y equal 0. So this will become 12x plus 8 times 0 equals 50. Remember, when we're calculating our intercepts for this moment in time, we don't have an inequality anymore. We put equals because we're actually solving for a value. This is gone. We get 12x equals 50. To solve that, we'll divide both sides by 12. Go ahead and use your calculator to divide. It will be a decimal, and that's okay. When I do 50 divided by 12, I get 4.16666 repeating. So we'll round that to 4.17. That's my x-intercept. To write an ordered pair with this, you calculated x is 4.17, and you had let y be 0, so comma 0. To find the y-intercept, let x equal 0. So let's do that. 12 times 0 plus 8y equals 50. 12 times 0 is 0. I bring down the 8y equals 50. I will divide by 8. Divide by 8. Go ahead and figure that out. What do you get? We get y equals 6.25. As an ordered pair, you let x be 0, so 0, comma, 6.25. We're ready to graph our points. So on the next page, you have a graph. I will copy over these points to help us out. So our two ordered pairs that we calculated were 4.17, comma 0 and 0, comma 6.25. These are the intercepts we just calculated. So 4.17, comma 0. I apologize, this is a little bit off. This should be here. So 0. Sorry about that. So 1, 2, 3, 4. 0.17 will be a little bit right here, a little after 4. Then my y-intercept that doesn't help. Pretend like this y-intercept is lined up right there. 0 means I don't go left or right. I'm just going to go up. 1, 2, 3, 4, 5, 6. 0.25 is a little more than 6. The original inequality was 12x plus 8y less than or equal to 50. The or equal to part tells me that I will have a solid line. Use your straight edge, make it nice and neat. To know where to shade, we have to check a point. So 0, 0 is up for grabs because my line does not go through 0, 0. So let's check 0, 0. That will be 12 times 0 plus 8 times 0 less than or equal to 50. 0 plus 0, both of these become 0. 0 is less than or equal to 50. This is true. So I shade this half. Remember, let's be neat. Please use lines like this. It's a nicer end result than just scribbling all over one side of the graph. Make it neat. It would be nice to put some labels on here. So if I go back and I look, X was driving games, and Y was basketball games. So let's add some labels. X equals number of driving games. My x-axis. And then Y is number of basketball games. Question E asks, is the ordered pair -4, 1 a solution of the inequality y or y not? Well, when I look at -4, 1, that would be 1, 2, 3, 4, 1. So technically, yes. So -4, 1 is part of the shaded region. But it's not part of the real world answer. Can you reason on why not? So the question, why is this not a real world solution, comes from reasoning on, excuse me guys, I gotta pause it for a second. If I were to write -4, 1, sorry guys, my voice sounds funny, but suddenly I can't talk right. -4 is driving games. You cannot drive -4 games. All right, let's try this again. Sorry for all the coughing, guys. Got some cough drops. Hopefully that will help. So, coming back to our questions here, we're going to start looking at specific points to remind us of what we have, especially because when I printed this to Smart Notebook, the axis shifted a little bit. And here, like this is supposed to be 1, but the line is a little dark here. Let's put some labels. So this intercept was 4.17, 0. And this was 0, 6.25. So part F says, watch the edge. So this is going to be a warning about assumptions that we make. It says plot 3, 2 and 1, 5. So let's go do that. 1, 2, 3, 2 would be right here. 1, 2, 3, 4, 5 is right here. So it's possible, depending on how you drew your line. Like if I just shifted this over just a little bit, 1, 5 might be on your line. So that's why we're talking about the edge, and there's a warning about the edge, so that's why. So let me label this as 1, 5. So we're going to look at these points and see if we can realize or figure out why are we getting a warning. Depending on your line, these points may or may not appear to be a solution. Check each point algebraically using your inequality in part B to determine if one or both or neither is a solution. So My original inequality was 12x plus 8y less than or equal to 50. Let's first check 3, 2. So where we see x, we're going to plug in 3, and where we see y, we're going to plug in 2. So this will be 12 times 3 plus 8 times 2 less than or equal to 50. Can you pause for a second and see if this comes out true or false? When I do the math, 12 times 3 is 36. 8 times 2 is 16. 36 plus 16 is 52. Is this true or false? Is 52 less than or equal to 50? No, false. So that one didn't work. Let's go look at 1, 5. So check 1, 5. That'll be 12 times 1 plus 8 times 5 less than or equal to 50. 12 times 1 is 12. 8 times 5 is 40. Less than or equal to 50. Again, this is 52, not 50. And when I look at my inequality, is 52 less than or equal to 50? No. So both of those ordered pairs failed. Neither point is a solution. So that's the warning about careful on the edge. So if we come back to our graph, what do we have as solutions? I'm going to get rid of this highlighter part. We're not going to pick points on the edge because we just realized that the edge is dangerous, right? Depending on our graph, a point could or could not look like it works, and we just proved that 2 that looked like it worked did not work. So grab a highlighter. Our real world solution is right here. We cannot have negative basketball games, and we cannot have negative driving games. So everything else that's not highlighted right now is technically part of the algebra solution, but it is not part of the real world solution. G says, find one additional combination of 12.8 point games you can play. So if we go look, we want to pick something that's clearly in the blue for me, or maybe yours is yellow, clearly in this triangle. So this would work. This would clearly work. So this would be 1, 2, or excuse me, this is my 0. 1, 2, 1. That works. This would be 1, 1, 2, 3, 1, 3. So 2, 1. What did X represent again? Well, if I look at how I labeled my graph, X is driving games. So 2 driving games and 1 basketball game. That's a combo that could work. Or 1 driving game and 3 basketball games. That could also work. So that's for 1. I showed you 2 just to show you that you really do have options. And we are done with this example. Let's do another one together. Eric plays football. His team's goal is to score at least 15 points per game. Right there, I get the sense of a total, so I'm just going to circle that and say greater than or equal to 15. Touchdowns were 6 points. Field goals were 3 points. Eric's league does not allow teams to try for the extra point after a touchdown. Write and graph an inequality that models the possible ways Eric's team could score points to reach their goal. So we'll underline the question. So the possible ways Eric's team could score points is by a field goal, a touchdown, number of touchdowns. Let's let X be number of touchdowns. Or
attention, please. Gabrielle Pace. Gabrielle Pace.
Number of field goals. That's the possible ways of scoring in their league. So what do we know about touchdowns? Touchdowns are 6 points. So this will be 6x plus field goals are 3 points. So plus 3y. And we're at the top, we had been told our total of at least 15 points. Now that we have our inequality, all we need to do is quick graph by intercept. So if you could, pause the video, find your intercepts, and shade. To get you started, if you're not sure, the first mini title will be X intercepts, let Y equal 0. So pause here. I'm actually going to pause it myself, and when I press play, I'll have my work done. So you press pause, and I will press pause, and then we'll compare. So this is what I got. For my x-intercept, I got 2.5, 0, and for my y-intercept, I got 0, 5. If we agree, awesome, we'll graph together. If not, press pause, compare your steps to mine, and let me know if you have any questions. So 2.5, 0, this is 2, this is 4, that makes this 3. So 2.5, 0 will be halfway between 2 and 3. 0, 5 means don't go left or right, just go up. 2, 3, 4, 5. From the inequality sign, I know that this will be a solid line. Make it very neat. Use a straight edge. And to know which side to shade, we need to check 0, 0. So you and I will both pause here, check 0, 0, and just decide which side to shade, and then we'll see if we match. So I'm back. This is the result of my check. 0 greater than or equal to 15, and the question is this true or false? This is false. So that means we shade the other side. Neatly, please, preferably with just straight lines of some sort, like so. But again, there is an algebra side to this solution and then a real world side. Here, we already have our label. This is number of touchdowns. I cannot have negative numbers of touchdowns. So when I look, this part right here is not part of the real world answer. My real world answer is here, here, here. For people who like to scribble, feel free to scribble here with a highlighter. Just this first quadrant. So none of this and none of this, because this would mean negative touchdowns, negative touchdowns, and this would be negative number of field goals, which is not okay. Use the graph to determine a possible combination. So any combination in what we highlighted works. So for me, I don't know, I'll pick 8, 7. Any ordered pair, any combo in this blue shaded region works. For me, I chose 8, 7. State your answer as an ordered pair. We just did that. And then explain what does it mean. So as a sentence, they could score 8 touchdowns and 7 field goals and score at least 15 points. Another answer could have been 4, 1, 4 touchdowns, 1 field goal, or don't want to get too close to the edge, 2 touchdowns, 4 field goals. Any ordered pair here works. Your friend is convinced 6, negative 6 is a solution since it lies in the shaded region. So let's go find 6, negative 6. That would be right here. They're convinced. What would you tell them? Applying the same reasoning from before, 6, negative 6 is part of the shaded region, but not part of the real world answer. We kind of help them to see that negative 6 would mean negative 6 field goals. You cannot score negative 6 field goals. If anything, that would be 6 missed, right? No points. 6 missed field goals. If Eric's team scores 1 touchdown, they need to score at least how many field goals? No, I take that statement back. I want to take back the missed part. It's just not possible. We can't even attempt to have that kind of real world meaning. You cannot have negative field goals. Okay? All right. Part F. If Eric's team scores 1 touchdown, so let's go look at the chart. 1 touchdown is here. That looks like 2, but maybe it's 3. I don't know. If I shift the line just a little bit, still through the points, but watch what happens. Even if I go like that, now that looks like 1, 3. Before it looked like 1, 2.5. So let's reason on this right here. 1, 3 with a question mark because we're just not sure. From the graph, it looks like this could be the answer, but let's see if we can prove it. So our original function, again, was our inequality, 6x plus 3y greater than or equal to 15. Let's check the point. When in doubt, check it. Okay, so 6 times 1 plus 3 times 3 greater than or equal to 15. That's 6 plus 9 greater than or equal to 15. What is 6 plus 9? 6 plus 9 is 15. Is this true? It says 15 greater than or equal to 15, so that is true. So we need to score at least 3 field goals. If this had failed, if 1, 3 had failed, automatically we would then look at 4 and see if that worked. These notes are officially complete. There is one more extra practice example included. I will continue with number 4 as one more, just in case it would help you be comfortable. If you feel like you have a good grasp of it, then your notes are done. But for those of you who would like to hang out for about 5 more minutes, we'll do one more. Sophia has $2 to buy oranges and apples. Oranges cost 45 cents each and apples cost 25 cents each. Write and graph an inequality that models the possible ways Sophia could spend her $2. So she's got up to that much money, and she's buying apples and oranges. And I'm trying to find out how many of each she can buy. So that means that X will be number of oranges. And I just said that because oranges came first. And then let's let Y be the number of apples. If you could, pause here and try to write the inequality for yourself, and then we'll see if we match. Let's see what you got. I got 0.45x plus 0.25y. Now you have to reason on how to translate this. How is she going to spend her $2? And that's not really a math thing. That's more like a common sense life thing. Like if you walked into the store with $2 in your pocket, can you spend more than the $2 or up to that? Well, to not get in trouble, you can spend up to that amount. So less than or equal to 2. Now that I have my inequality, we are ready to graph by intercepts. You pause, hit the spacebar, pause, and I'm going to pause mine. Let's both do the intercepts, and then we will compare answers. Here are my intercepts. I got 4.44, 0, and then 0, 8. So if we agree, awesome, we'll move on together. Otherwise, press pause again, and then compare yours to mine. To graph, let's get some labels. X is number of oranges. Y is number of apples. So that's 4, 5, 6. So this is 5. So 4.44 is like roughly there. As long as you don't put it on 4, I know that you know it's between 4 and 5. 0, 8. From the inequality, it's a solid line. It's not a dashed line. Please make it straight with a straight edge or your ID. Let's test 0, 0. Check 0, 0. So I'll work on the check while you work on the check, and then we'll compare. I got 0 less than or equal to 2. True or false? True. So that means that we shade the side 0, 0 is on, which is this side. But we realize that the entire half plane, like all of this, is not the answer. Only the real world answer part. Just that piece. For D, E, and F, I would like you to try these. At the start of class tomorrow, before we do our class practice, I will post answers based on what you all contribute to the conversation. So this finishes the notes. The homework side of this, I will pass out at the start of class tomorrow for us to practice. Nice job. Have a good day.